This is Flowline Chronicles, stories of water, people, and the future we share. When rivers flood, we often blame water. When channels rise, we blame poor maintenance. And when embankments fail, we call it an engineering lapse. But beneath all these visible symptoms lies a quieter force, one that shapes rivers more deeply than flow alone. Sediment, sand, silt, and clay, carried invisibly, deposited gradually, decide how rivers move, where they overflow, and how stable their banks remain. In this episode, we look beyond water to understand how sediment quietly governs the fate of river infrastructure. Sediment is not waste. It is the river's building material. Every grain carried downstream is the result of erosion upstream, from mountains, slopes, floodplains, and riverbanks themselves. Rivers do not just transport water, they transport landscape. Their channels adjust continuously to balance how much sediment they receive and how much they can carry forward. When this balance is disturbed, the river responds, slowly but decisively. Indian rivers are among the most sediment-laden in the world. The reasons are structural, not accidental. The Himalayas are young and fragile, constantly eroding under gravity and rainfall. The monsoon delivers intense, short-duration flows that mobilize enormous volumes of sediment in weeks. Deforestation, agriculture, and expanding settlements increase surface erosion across catchments. And dams and barrages interrupt sediment continuity, trapping material upstream and starving downstream reaches of natural balance. What reaches the plains is a river already carrying more than it can easily move. As sediment accumulates, riverbeds rise. The channel becomes shallower. Its capacity to carry floodwaters reduces. Floods begin to spill sideways, not because rainfall has increased alone, but because the river has lost depth. Raised beds also increase lateral pressure, forcing rivers to erode their banks more aggressively. Embankments grow taller each decade, yet floods arrive sooner and spread wider. A river choked with sediment floods not because it carries too much water, but because it has forgotten how to move. Our most common response is dredging. Sediment is removed, temporarily restoring depth, until the next monsoon replaces it. Confining rivers between embankments pushes sediment deposition downstream, shifting the problem rather than solving it. Treating sediment as waste forces rivers into rigid forms they are not designed to maintain. These approaches manage symptoms, not systems. More resilient river engineering begins with acceptance. Sediment must be budgeted, not eliminated. Floodplains must be allowed to function as relief zones. Channels must be given room to adjust, not forced to freeze. Adaptive corridors, controlled inundation zones, and continuous monitoring allow infrastructure to evolve alongside the river. Here, engineering shifts from domination to negotiation, from permanence to preparedness. Rivers will always carry sediment. That is how landscapes are built. The future of river engineering depends not on how much water we can control, but on how well we understand what the river carries with it. Sediment is invisible, but its consequences never are. Flowline Chronicles, where every story reminds us of the delicate balance that keeps us alive